Example 1, describe the transformations that must be performed to obtain the following graphs from the graph of y equals sine of x. So we're going to compare this to our general form, y equals sine x minus d plus c. A, D, and C are very similar to A, H, and K in the quadratic function, and they have the same roles as A, H, and K in the quadratic function. A, if it's negative, is responsible for reflection in the x-axis. Also, if you ignore the sign and the number happens to be greater than 1, then A is responsible for a vertical stretch. But if the number happens to be between 0 and 1, then it's responsible for a vertical compression. The number that's being taken away from x is d, and d is responsible for horizontal translations. If it's a positive number taken away from x, it's a horizontal translation to the right, and if it's a negative number that's being taken away from x, then it's a horizontal translation to the left. And then the last letter C, that's responsible for a vertical translation. If the number that's being added at the end is positive, the translation is up, and if it's negative, the translation is down. So here we can clearly see that the value of A in this case is -2. The value of D is the number that's being subtracted from x, so if I rewrite this as a subtraction, it would appear as x minus -10. So D is actually -10 here. And C is the number that's being added at the end, so it's 3. So based on these values, what we have here is, first of all, a reflection in the x-axis because the sign of A is negative. And then if we ignore the sign and look at the number, because this number is greater than 1, we also have a vertical stretch by a factor of 2. D is responsible for horizontal translations. So we have a horizontal translation, and because D is negative, it's going to be a horizontal translation 10 units to the left. And then C here is responsible for vertical translations. And since it's positive, it's going to be 3 units up. Okay, let's look at the next example. Here, A is 1/2. And D is going to be positive 90. We're subtracting a positive number here. And then since we don't see a value here at the end that's being added, that means C is 0. So we actually don't have a vertical translation. We don't need to mention anything there. So based on these values of A and D, here we can start by saying that we have a vertical compression by a factor of 1/2, since that A value is between 0 and 1. And D is responsible for a horizontal translation, and since it's positive, it's going to be a horizontal translation 90 units to the right. Okay, here's the last example here. The number that's implied here in front of sine of x is -1. So -1 is taking the place of A, so A is -1. There's nothing that's being taken away from x inside the brackets. That means D is 0. And the number that's added at the end is our C value of -8. Since D is 0, we cannot ignore this transformation of a horizontal translation. And we don't have to mention it. We just have to focus on the values of A and C. So since A is negative, we have a reflection in the x-axis. The value of 1 that we see means that the shape of sine of x is not going to change when compared to the original function, y equals sine of x. So we're not going to have a vertical stretch or compression. And then C is responsible for vertical translation. So since it's negative, it's going to be a vertical translation 8 units down.